Okay, I wanted to make a video to help you review factoring. So this is a factoring review, an overview of the strategies that hopefully you've learned in the past in Algebra 2, but they need to kind of come back to us. So the first is taking out a greatest common factor. This should always be what you look for first in any situation. So once you locate the greatest common factor, in this case, I can pull out a 2 and an x from both terms. You write the greatest common factor in front of a set of parentheses. Then you're dividing each of these terms by 2x. So what will I have left? I'll have left x plus 10. You can check your answer by redistributing the 2x. 2x times x is 2x squared. 2x times 10 is 20x. So in part B, you should be thinking in your head, okay, what is my greatest common factor? So my greatest common factor is 3x because I can divide each of these terms by 3x. What will I have left? X squared plus 7. And I can check my answer. 3x times x squared is 3x cubed. 3x times 7 is 21x. So that's the greatest common factor method. Next is the difference of two squares. A perfect square is a number like 1, 4, 9, 16, 25. Those are perfect squares from geometry that you should recognize. So x squared is a perfect square and 100 is a perfect square. The pattern that you're going to factor these into is x plus a number, x minus a number. So I take the square root of x squared to get x times x. I take the square root of 100 to get 10 times 10. One of my factors gets a plus and one of my factors gets a minus because remember when you multiply binomials, you do FOIL. So first, x times x is x squared. Outer plus inner, see how they're opposite of each other? Negative 10x and positive 10x. That's why there is 0x in this original problem. And then 10 times negative 10 is negative 100. So in part B, we're just going to take the square root of each of those terms and put one with a plus and one with a minus. So 2x times 2x is 4x squared. 5 times 5 is 25. And then whichever one you want to put a plus in and whichever one you want to put a minus in. So you could put the minus here and the plus here if you wanted to. And it says, note, can you factor x squared plus 9? And this says no, because you can't factor a sum of squares. So let's just look at this example. What if I tried to make that like x plus 3 times x plus 3? I just want to remind you why this doesn't work. So this doesn't work because when I FOIL this out, I get a middle term, x squared plus 3x plus 3x plus 9 is x squared plus 6x plus 9. See how that is not x squared plus 9? So it's the actual outer and inner being opposites that allow us to be able to do this problem. So you cannot factor sum of squares. You would just say that's prime. The next strategy is, so 3 and 4 kind of go together. They're both trinomials. Just something special happens in 3. But we can still use the diamond method for all of these problems. So in the diamond method, what you were taught is we're looking for the factors of 16 that add up to -8. So you might have learned the diamond last year. So what are my factors of 16 that add up to -8? -4 times -4 is positive 16. -4 plus -4 is -8. These are part of your factors. So your factors are x minus 4 times x minus 4. See how when you FOIL that back out, x times x is x squared, -4x plus -4x is -8x, and -4 times -4 is positive 16. A perfect square trinomial can be written as just that one factor squared. Either way, to write your final answer is fine. So in part B, we're looking for the factors of 36 that will add up to 12. So I think you know that that would be 6 times 6. That's part of my factor. So my factors are x plus 6 times x plus 6. And perfect square trinomial I could write as just x plus 6 squared. So in example 4, they're going to be the same strategy as the diamond, but they're going to come out as a different factor, like not two of the numbers that are the same. So let's try 40 and 14. Can you think of the factors of 40 that add up to 14? For example, 5 times 8, 20 times 2. How about 4 times 10? So those go inside my factors. X plus 4 times x plus 10 are the factors. So you might want to pause the video and try examples B, C, and D on your own, or you can just follow along with the video. I'm looking for the factors of 32 that add up to negative 12. So let's think. If this is positive, these are both going to have to be negative. So probably what? Negative 8 times negative 4 is 32. So x minus 8, x minus 4. So on this one, I'm looking for the factors of positive 48 that add up to negative 14. So again, I'm looking for two negative numbers that will multiply to a positive. So let's see, 6 times 8 is 48, right? So negative 6 times negative 8 would give me positive 48. And if I'm going too fast for you, just pause the video, try it on your own. You could slow the video down, you could speed the video up on YouTube. In example D, I'm looking for the factors this time of negative 5 that would add up to positive 4. So I'm looking for one of these numbers to be negative and the other one to be positive. So let's see, positive 5 times negative 1 would give me negative 5 and would still add to positive 4, right? X plus 5 times x minus 1. All right, so two more strategies to go over. And actually, the grouping method we're going to go over optionally today, but we're going to look at it more next class. So the last one you learned in Algebra 2 was called the box method. There's 3 terms. There's no greatest common factor that you can pull out. You've got a bigger number here in front of x squared. If you notice on this page, in front of x squared, we just had x squared by itself. They all had a coefficient of 1. So this time, you're going to start filling out something called a box. It's called the box method. And you're going to put, basically, this trinomial is going to go inside the box. So you're going to start by putting 3x squared and negative 5 in the box. Now, negative 14x is going to get split up strategically between these two boxes. So you have to figure out how to split up this negative 14. So you use the diamond method again. Instead of putting negative 5 up here, this time, because there's a 3 there, you're going to have to do 3 times negative 5 is negative 15. And then negative 14 still goes in the bottom of the box. So I'm looking for the factors of negative 15. So I need one positive and one negative number that add up to negative 14. So negative 15 times positive 1 actually is what's going to go inside our box. We were trying to split up negative 14x. So I'm going to put negative 15x and 1x in the two separate boxes. See how that adds up to negative 14x together? So once you have your box filled in, you're looking for factors outside the box that when you multiply them, you get the numbers inside the box. So 3x times x, but I strategically want to put the 3x here and the x here because I'm trying to go down the line and get negative 15x over here. So see how 3x times negative 5 will give me the negative 15x. X times 1 will give me 1x. Negative 5 times 1 will give me negative 5. So my solution, my factors, are going to be x minus 5 times 3x plus 1. And the box method is definitely the most challenging. So if you need some help with that, please don't hesitate to ask. All right, so you could pause and try part B on your own, or you could just do it along with the video if you'd like. So I'm going to put 2x squared and then 4. I'm going to do the diamond. 2 times 4 is 8. I'm looking for them to add up to 9. So that would be 8 times 1. So this 9x is going to get split up into 8x and 1x. Doesn't matter which box you put these in. So now I need to get 2x squared. So 2x times x. See how I strategically put 2x in this row so I can get 8x over here? I'm going to put a 4 here because 2x times 4 is 8x. X times 1 is 1x. And 4 times 1 is 4. So I know that it worked out. So my answer is x plus 4 times 2x plus 1. So if you just use the box method, like for example on number 1 down below, that is fine. I just want to show you what the grouping method looks like in case any of you came from a different system that learned grouping, like a different school, a different class. Go back up here to this first step. You do this first step the same way. You want to figure out how to split up negative 14x strategically. The negative 15 and 1, instead of writing all of these 4 numbers inside the box, you write your problem 3x squared minus 15x plus 1x minus 5. So you write them out as 4 separate terms. It doesn't matter the order that these 2 terms are in. Whoever's next to them as their friend, they get grouped together. You take the greatest common factor out of each sets of parentheses. So I'm going to pull out a 3x, and what am I left with? X minus 5. And then here, the greatest common factor is just 1, and see how I'm left with x minus 5 in both of those cases? Well, now I'm going to pull out the x minus 5 from each of them. What do I have left? 3x plus 1. See how my factors come out the same? So if you were going to write out part B the same way, you'd have 2x squared plus 8x plus 1x plus 4. See if you can finish this one by grouping yourself and then come back and check the video. Greatest common factor is 2x times x plus 4. Greatest common factor is 1 times x plus 4. The x plus 4's come out, and I'm left with 2x plus 1, which is the same answer that I got up here. I should get the same answer. So I just wanted to do like 2 more problems with you, and I wanted to show you the quadratic formula, and then you're going to finish the rest of this guided practice on your own. And please ask for help if you need some help. So this looks like I can't take out a greatest common factor. I noticed that this says equal to 0, so I just wanted to review what that means. So I'm going to set up the box method. So I have 2x squared and 12 going into the box. So I'm going to put 2x squared up here. Oh, sorry, not 2x squared. My bad. In the diamond, I'm going to do 2 times 12 is 24. I'm going to put 11 in the bottom. Forgot what I was doing. I'm looking for the factors of 24 that add up to 11. So that must be 8 times 3. So I'm going to put 8x in one box and 3x in the other box to get my factors. Now I'm going to do kind of the greatest common factor. I can get 2x here. 2x times x is 2x squared. 2x times 4 is 8x. X times 3 is 3x. 4 times 3 is 12. There are my 2 factors. So the reason I wanted to show you this example is because this equals 0 means that it's looking for the x-intercepts. So these are the factors. How do I take factors and find the actual solutions, the actual x-intercepts? I ask myself, what x value is going to make that 0? And the answer is -4, because if I plug in -4 plus 4 is 0, and 0 times anything is 0. It's called the zero product property. So -4 is one of my solutions. Now this one, the answer is not just -3 because of this 2 coefficient. So you're going to take 2x plus 3 and set that equal to 0 and solve for x. So my first step would be to subtract 3 to the other side, and my last step would be to divide by 2. So my answer is actually -3/2. So I have 2 solutions there. So you can try these. I'm just going to skip over. I wanted to show you one with the quadratic formula when it's not factorable. So how can I tell if something's not factorable? Well, first of all, I need it to be 0 over here. So this one actually is factorable because when you subtract 1 from both sides, 5x squared minus 10x, that's going to equal 0, and you can do a greatest common factor on that one. So I'm going to skip that one. I'm going to go to number 6. I can tell this is not factorable because when I do 7 times 1 and get 7, the only factors of 7 are 7 times 1. How am I ever going to get -1 as my sum? So let me review with you the quadratic formula. The A value is 7, the B value is -1, and the C value is 1. Those are the coefficients of each of the terms. You plug those coefficients into the quadratic formula. So the opposite of B, the opposite of -1 is +1, plus or minus the square root, B squared. So -1 times -1 is +1, minus 4 times A is 7 times C is 1. I'm just plugging in numbers all over 2A. So 2 times 7 is 14. So I'm going to use my calculator and actually figure out those solutions. So I'm going to do 1 plus the square root of 1 minus 4 times 7. And it tells me there's no real answer because I just got -27 under here. 1 minus 28 is -27. So even though I did the quadratic formula, there's still no solution. So you're going to try the rest of these guided practice problems up through number 13. Ask me for some help. Oh, and yes, you're only doing 0, 1, 1, right? So you're doing going back to this previous page and going up through number 13 and submitting that on Google Classroom.